The sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
That's a right triangle, you idiot!
In this video, we're going to prove that the sum of the three angles formed within a triangle actually add up to 180 degrees using some of the theorems that we studied in our parallel lines unit. So the theorem that we're trying to prove is that the sum of the measures of the angles of a triangle is 180. So I'm basically given triangle ABC, and I'm trying to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. Now, in order to accomplish this task, before I start proving it, I'm actually going to add something to this diagram that I'm going to use in a couple of minutes. So I'm going to draw in or construct a line parallel to AC through the point B. So I'm drawing this line through B and this other point D, which is going to be parallel to AC. And that's going to be how I've constructed it. And it's going to be a new given that I'm adding to this information. So I'm constructing this parallel line. So now let's actually go ahead and try to prove this information. So the only givens I have is that ABC is a triangle, which I can visually see in my diagram, and the fact that I've added this parallel segment. So I can also write into my diagram, I can draw that these two segments are parallel, or I should say this segment and this line are parallel to each other visually. And I'm also going to add in a couple of other angle numbers that I think are going to be helpful. So I'm going to add an angle number 4 here and an angle number 5 here. Okay. So now, because these lines are parallel and angle 1 is alternate interior to 4, I can say that angle 1 is the same as angle 4 because lines are parallel if and only if their alternate interior angles are congruent. And at the same time, in fact, in the same step for the very same reason, I can say that angle 3 is congruent to angle 5 because they are also alternate interior to each other. So for this same reason, in the same step, I'm going to say that the measure of angle 3 is equal to the measure of angle 5. And just recall that it's also equivalent to saying that the actual angle 1 is congruent to angle 4 as it is for their measures to be equal. Okay, well, if you notice now, the reason I drew in that parallel line should start to be come a little bit clearer, because what I'd like to now say is that 4 plus 2 plus 5 add up to 180. So I'm probably going to be using the angle addition postulate. Now, one caveat about the angle addition postulate is it only works with pairs of angles. So first I'm going to say that the measure of angle 4 plus the measure of angle ABD, so it's this whole angle ABD plus 4 is 180, using the special case of that angle addition postulate. And at the same time, I'm also going to say that ABD, this larger angle, is the same as 5 plus 2. Then I'm going to go ahead and substitute into this equation what the measure of ABD is. So I got around that problem that the angle addition postulate only works with a pair of angles. So I can now substitute that in, and I get the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is 180. But remember, my goal was to show that 1 plus 2 plus 3 was 180. Well, now I can actually do that by replacing the measure of angle 4 with the measure of angle 1, because they're equivalent to each other. And I can also replace the measure of angle 5 with the measure of angle 3, because they're congruent to each other. So in this same step of substitution, I'm going to do one more substitution by replacing those values. And I actually end up with the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. And I've shown, using just a couple properties of parallel lines and those properties of equality that we've done earlier in the year, that given any triangle, ABC, the sum of the three measures of their angles has to be 180 degrees.